Welcome to GRS Electronics. Here today, as per the requisition of so many subscribers, I am starting the basic electronic tutorials. The main concept of this GRS Electronics hobby tutoring is it is a technical subject for non-technical people. So this means non-technical people, they don't need to know the depth of the technicality of the subject. So I will take you in such a way that you will follow each and every component level and the schematic level and all these levels, so that you will understand and immediately you can assemble circuit diagrams and you can enjoy the projects. So this is how this lessons will be on this tutoring tutorials. So first of all, in electronics, when you take, I am not going to go in depth of starting from the atoms, protons, neutrons and all these things. So I directly deal with the components, component level, and the functionality of the component symbol, and how you can read a circuit diagram, so that given a circuit diagram you can assemble your own circuits and then you can enjoy the projects. So this is how the tutoring is going to be. So first of all, what you have to understand is, in electronics there are only 10 components. These 10 components leads to the combinations of other components. So that's a basic in electronics. If you know 10 components thoroughly, so that you can build your own circuits and you can know a lot of things. As a hobby, you will enjoy. Definitely you will. Those components are as follows. One is resistor, capacitor, diode, transformer, inductor, transistor, relay, SCR, triac and IC. So these are the 10 components. So from these components, as when you see the first component as resistor, so in resistor there are different types, that is fixed resistor, variable resistor, and then light dependent resistor, then temperature dependent resistors. So like this. So the basic of the component is the same, but depending upon the environmental issues, the components have different names. So this is how it is. So that is why I told you, first the 10 basic components one have to know. They have to know by how it functions and what the symbol is, so that it will be easy to read the schematic diagrams and to assemble the circuits and enjoy the project. Now I will show you the components, and side by side I will show you how the components looks like, so that practically you can see as well as you can learn. So as I told you, here I prepared an electronic components chart. So here there are 3 rows. One is the name of the component, and then the item, how the component looks like in the real world, how it looks like, and then the representation of the component in symbolic form. So the first item here, what you see on top, is the resistor. So in resistor, when you see, you can see so many types of resistor. You have variable resistor, you have light dependent resistor, you have presets and all these things. So in resistors itself, you see there are some 2-3 types of resistor depending upon the power. So when the higher the power, the resistor looks little bigger. So in the first white in color, it is a 5 watt resistor. Then you see a 2 watt resistor. Then you see a quarter watt, that is 1/4 of the watt resistor. You have half watt also, and likewise you have different wattage resistor, 1/8 watts also you have. Now to your left down, you see a blue component which is called a preset. Preset is nothing but a variable resistor which is in a small form, where this is mounted on a PCB, that is printed circuit boards. On your right side, you see a variable resistor which looks little bigger in size, and there is a plastic shaft on it. So this you can see in your amplifiers and in your radios, all this volume controls, treble, bass controls, and all these controls. Those are all the variable resistors. So this is one type. So that is how once you take resistor, you see how many types of resistors you have. So you have in the bottom you can see that LDR, which is a light dependent resistor, the resistor which depends on light. The same way, the resistor, when it depends on temperature, you have a resistor depending on temperature, which is called as thermistor. Okay, so this is how that formation is. Now next we switch on to the diode. So diode is nothing but it is an electronic component which allows current only to pass in one direction. It is like a one-way valve. So it functions, the function of the diode is like one-way valve, and it is the only component in the whole electronic component which converts AC into DC. So the AC current, when it is converted to DC current, you have to use a diode. So that is the main function of the diode. On the top you see a black cylindrical part with 4 leads. That is diode, the 4 diodes which is encapsulated in a small cylindrical form, which is called as the bridge rectifier. It is called the bridge rectifier. So next to that, a small diode you see, that is a 1 ampere diode, that is a normal diode, and below that you see a little bigger diode, which is the power is more, which is 3 ampere diode, and then the below you see a very small diode which is written as ZN, which is called the Zener diode, and on your right hand side you see red colored one which is called the LED, light emitting diode. So for all these things, what all I've told you so far, you can see the symbol. On the symbol side you can see the first thing is, this is also a 2-lead component, but when it comes to a bridge rectifier, it is a 4-lead component. So now the first that small diode, normal diode, which has 2 lead, one is called the anode and the other is called the cathode, which you see on the first symbol in that symbolic side, the first diagram. The first one is that. The second is the below that first one, which is where you can see the 4 diodes. So that is called as the bridge rectifier. So next you see that Zn, which is called the Zener, and you see the symbol there where you have an integrated symbol on the top side of the triangle. So that is a Zener diode, and finally you see a LED, light dependent resistor. So you see 2 arrow marks which is emitting from the diode. So it symbolizes the emission of light. So that is why it is light dependent resistor. So likewise, so different electronic components have different functions. So if in a diode itself you have so many different varieties. At the same time, in resistors also, as you have seen, there are so many varieties. So but the basic is, it is a resistor and it is a diode. So the third one, now we come to capacitors. Capacitors, where there are 2 types. One is polarized and the other is non-polarized. Polarized capacitors have that plus and minus symbols, but in non-polarized there is no plus or no minus, where you can connect the leads in any direction you want. But in the polarized one, you have to connect as per the polarization, that is plus or minus. You cannot reverse and connect it. So the first one, what you see, that orange color one, it is a polarized capacitor. So in the polarized capacitor, on the side there is one small minus sign printed on it with a black arrow mark, where you can see that you can see, and I will show you also a little later, and that denotes the minus. The other opposite side is the plus one. But in non-polarized, as you know, there is no any symbol. And then for all these components, first I am explaining this component, and then after that one by one I will explain the functionality of the component, which is very important. So now comes the transistor. It is a 3-lead component. So far we have seen a 2-lead components, that is resistor, diode, capacitor. These are all 2-lead components. Now we are going to see a 3-lead component, which is called the transistor. So the transistor normally has 3 leads, and there are 2 types of transistor. One is NPN and PNP. So N stands for negative, P stands for positive, and again N stands for negative. This likewise, P stands for positive, N stands for negative, and P stands for positive. So these are the 2 types of transistor. So in symbol, transistor symbol, if you can see, you can differentiate this NPN and PNP based on that arrow mark which is coming out of the base. So once you see the transistor, it has got 3 leads. The 3 leads are named as emitter, base, and collector. So the transistor, as you can see, there are different types. Again, the transistor also depends upon the power. So normally a general purpose transistor is a small transistor, which you can see that a black one, and then there is higher power, that is it can withstand even 50 to 100 amperes. And the metal can, what you see here, it is again say 1 watt, 5 watt, 10 watts, 25 watts, and depending upon the wattage, the transistor size also differs. So that is why I have given here different types of transistors of different powers. So this is how a transistor exactly looks like. So now again, next to the transistor is an inductor. So again, inductor is a 2-lead component, and it can be 3-lead component, or even it can be 4 to 6-lead component, depending upon the which is wound on a whatever media it is to be wounded. So a piece of wire, when it is made as a coil, then it becomes a inductor. That is how you call it as a inductor. So next to that you have the integrated circuit, IC. IC means integrated circuit. Integrated circuit is nothing but the combination of large or you can say a complicated circuit which is compressed, and then it is formed in a very small area. So that is how a IC looks like. So you can see different IC here I have given. So if you have a single lead in a single side, it is called a SIL, single inline chip. So if you see double leads on the double sides, then it is called as DIL, that is dual inline. And so this is how the ICs are formed, and when the number of pins increases, the complexity of the ICs also get increased, the functionality gets increased, and the outputs gets increased, and everything gets increased. So this is how the complication starts. So now next we come to relay. Relay is nothing but a coil and a switch. So when you pass current to a coil, the coil get energized. So when the coil get energized, it gets magnetized. So with this magnetic function, the switch gets on or off. So this is called a relay. Then this relay also has a function of inductance which is inside it. So next comes your SCR. SCR is nothing but silicon controlled rectifier. So this is also like a relay. It is like a relay where when you give, because there are 3 lead, it's again a 3 lead component. So there is a gate, there is a pin called gate. So in this gate, it requires a very low voltage and low current when it is given to the gate. So the anode and cathode gets conducted. So the anode and cathode can be on a higher voltage or whatever type it is. So when the gate is biased, so this anode and cathode gets connected and it switches on. So this is also switches, but this SCR is a silicon controlled rectifier, works on DC. So here triac is nothing but a 3 lead component which operates on an alternating current AC. So there are two leads, one is A1 and A2, and again there is G. So the G is nothing but gate. When the gate is biased, so what happens, the A1 and A2, the two terminals get connected, and you can switch large AC circuits on that. Even with higher powers also you can switch depending upon the power. The triac also looks like something like the transistor. You see a black one which is in the transistor with 3 leads, so it looks like that. And even the triac has a metal metal can also, where you can see the transistor which is in the metal form, the power transistor. So a triac can look like that also. So these are the description of this components. And next I will go to the function, what are the functionality of the components.